I am Professor Kiran Vajpayee, HOD Chemistry Department, Government Bilasa Autonomous Girls PG College, Bilaspur. Today, my topic is local anti-infective drugs. This is the paper 3rd, Medicinal Chemistry of the class MSc 4th semester. Dear students, today I am taking the chapter Local Anti-Infective Drugs. The drugs which are used to control the infections of body are known as anti-infective drugs. Infections in the body are caused by viruses, bacteria, worms, protozoans, fungi, etc. These drugs are classified into different classes according to their activity on the target. The classification according to this activity based, first is antibacterial drug. Antibacterial drugs, example sulfonamides and quinolines, some other antibiotics also. Antimycobacterial drugs. These antimycobacterial drugs are classified into again two classes. One is antituberculotic drugs and second one is anti-leprous drugs. These drugs are of two kinds, first line drugs and second line drugs. First line drugs means the drug which this type of drugs having acceptable toxicity. No doubt there are some toxic effect, but the toxicity is acceptable. And the second line drugs, this antituberculotic and anti-leprous drug having microbial resistance also. Third type of classification is anti-protozoal drugs. Anti-protozoal drugs means caused by protozoans, disease caused by protozoans, like malaria and so on, amoebiasis, malaria and so on. The drugs are chloroquine, primaquine, pamaquine, and etc. Next is anti-helminthic drugs. You know already the worms are generally present in the stomach of children, and the medicine of this class is albendazole, piperazine, etc. Next is antiviral drugs. Antiviral drugs means which are against viral diseases like acyclovir, vidarabine, etc. Now, I am giving you idea about the general mode of action. General mode of action, these drugs are having action on different sites of the target or the organism. These sites are cell wall of the target, means that bacteria, virus and so on, and cytoplasmic membrane. These drugs are used to break the cytoplasmic membranes. Protein synthesis, they inhibit the protein synthesis of these microbials, and nucleic acid metabolism. Nucleic acid metabolism also hindered by these drugs. So these are the 4 modes of action. Now, we are starting class wise. First one is antibacterial drugs. As by the name you can understand, antibacterial drugs means those are acting against bacteria. The drugs which are generated by the bacteria to cure this disease, we can use these drugs. Now see, antibacterial drugs according to your syllabus, I am taking the example only that is synthesis and uses of ciprofloxacin, norfloxacin and nalidixic acid. Ciprofloxacin is another trade name of this medicine is Cipro. The name of medicines, trade name of medicines given by different companies, so that one name is Cipro. Its chemical name according to its structure is 1-cyclopropyl, 6-fluoro, 1,4-dihydro, 4-oxo, 7 piperazine 3-quinoline carboxylic acid. And this is the structure of this drug. You can see it has piperazine nucleus, it has cyclopropene attachment, it has carboxyl group, azo group, fluoro group, and this quinoline nucleus. Because it is quinoline derivative, so it has quinoline nucleus. Now see the synthesis of this drug. We are going to start synthesis from this compound, 3-fluoro, 4-fluoro, aniline. You know this is aniline, in which this fluoro and fluoro group are at 3 and 4 position respectively are present. This is subject to reaction with this compound, and this compound is So we are going to synthesize this ciprofloxacin. We are taking this compound, that is 3-chloro, 4-fluoro, aniline. This is, and we are going to treat this compound with diethyl ethoxy methylene malonate. This diethoxymethyl malonate is then, when reacts with this compound, cyclization is take place. We are this reaction is going on in heat, in presence of heat. So we get this cyclized product. This cyclized product, you see that there is quinoline nucleus is formed. This is quinoline nucleus, and these are the groups we are attached with this. This compound is then treated with, in the first step with cyclopropyl iodide. Next, second step is reaction with N-methyl piperazine, and third step is hydrolysis. After these three processes, the product ciprofloxacin is obtained, and that is here. This compound is ciprofloxacin. So this is simple synthesis, simple condensation reaction and the cyclization reaction, and after methyl reaction with isopropyl iodide and some reaction, we get this ciprofloxacin. Properties and uses. This medicine, it has function against E. coli bacteria. It is also useful for urinary tract infection. Main application of this medicine is to remove urinary tract infection. But also it is useful in the treatment of infection of respiratory system, which is caused by the Mycoplasma delumella, as well as skin infections, typhoid fever, also cured by these drugs. Now the second antibacterial drugs is norfloxacin. Norfloxacin is also a quinoline drug, just like ciprofloxacin, and this trade name of this drug is Norvin or Noroxin or some other name also. The chemical name of this compound is 1-ethyl 6-fluoro 1,4-dihydro 4-oxo 7-piperazine 1-quinoline 3-carboxylic acid. Hence it has quinoline nucleus and these are the groups. Now we are going to synthesize this compound. And again we are taking chlorofluoroaniline, just like ciprofloxacin. And this another compound is also that diethyl ethoxy methylene malonate. And these two compounds on treatment, they condense together and they form this type of compound. Where this condensation takes place, the hydrogen are this, and this total group, this one, it will come out like this way and like this way. This all are going on, and the remaining part is fluorochlorophyll nucleus, as well as the part is coming from the malonic acid, malonates, thyminoids. Now, this then treated with this compound, and on heating, this gives this structure. Now see, here quinoline nucleus is formed, and these are the groups which are attached: fluoro, chloro, oxo, and ester group, ethyl form of ester. So this derivatives, this species is formed. Then after, this is subjected to treatment with ethyl bromide, triethylamine, tertiary amine, and after that NaOH. By these reactions, we get this species. This is carboxylic group unit, and this quinoline nucleus is formed. Now the last step is reaction of that species with the dihydropyrazine, and after the reaction of this pyrazine nucleus, this pyrazine nucleus is attached as a pyrazine form, and we get non-fluoxetine. Properties or uses: it is useful in the treatment of urinary tract infection, and as well as the genital infections. Typhoid fever may also cured by use of this drug. The side effects of this drug are nausea, dizziness, and anxiety. The third medicine which are using as antibacterial drug is nalidixic acid. Nalidixic acid, its trade name is Legram, and the chemical name of this compound is 1-ethyl 1,4-dihydro 7-methyl 4-oxo 1,8-naphthalene 3-carboxylic acid. This medicine is synthesized by using methyl aminomethyl pyridine. This is aminomethyl pyridine. This is treated with this malonate derivative, ethoxymethylene malonate, and just like ciprofloxacin and norfloxacin, condensation is take place, cyclization is take place, and we get this derivative. This derivative is then treated with ethyl iodide and sodium hydroxide. So we get nalidixic acid. Nalidixic acid is in the treatment ethyl iodide and sodium hydroxide, we get this nalidixic acid. Here, ethyl iodide, carboxylic, oxalatic acid. Now, properties and uses. It is effective against gram-negative bacteria that causes urinary tract infection. This drug absorbs very well in plasma protein up to 95 to 97%. Adverse effects are drowsiness, headache, visual disturbances, and rashes. We are studying about antimycobacterial drugs. Before this, I have given about idea about antibacterial drugs. Now we are seeing about antimycobacterial drugs. These drugs are active against mycobacteria, and mycobacteria are transitive state species between bacteria and fungi. Means neither it is whole bacteria nor it is fungi. It is the between these two. This is species having a structure. Mycobacteria are belonging to family that is Mycobacteriaceae. These pathogens are Mycobactericum tuberculosis, which causes tuberculosis, and Mycobacterium leprae, which causes leprosy. Means these two diseases, tuberculosis and leprosy, is caused by this mycobacterial bacteria. They are classified into two categories. Number one is first line drug. First line drugs which are means the drugs which are highly active highly effective with an acceptable toxicity. Means these drugs having toxicity, but this is acceptable. The example of this class is ethionamide. This example of this class is isoniazid, rimfen, and ethambutol. And the second line drugs are, it means these drugs used for microbial resistance, and these are ethionamide and aminosalicylic acid. These drugs acting against microbial resistance. So anti-tuberculotic drugs we are now seeing here. Now the next part is anti-tuberculosis drugs. Means the drugs which are used to cure tuberculosis. In this class, the first member is isoniazid. Isoniazid, we are going to see synthesis of this. The trade name of this drug is leniazid, and the chemical name of this drug is 4-pyridine carboxylic acid hydrazide. Now, the next step is synthesis. In synthesis, we are starting compound is ethyl isonicotinate. This is nicotinic acid, ethyl derivative of nicotinic acid. Iso derivative is here, and this is hydrazine. It is hydrated. So hydrazine is reacting with this nicotinate, and in presence of alcohol, this reaction is going on. Then we get this derivative isoniazid, where hydrazine derivative is attached. So this is isoniazid. It is biostatic drug. Biostatic drugs means drug which preliminarily arresting bacterial multiplication. So it inhibits formation of mycolic acid. Mycolic acid is important component for microbial cell wall formation. So by this way, it arrested the formation of microbes. Adverse effect are fever, rashes, jaundice, etc. ठीक है? Now, we have seen one anti-tuberculotic drugs before this. Now, another is ethambutol. Ethambutol, this trade name is mybutal. Now, it's very simple synthesis. The starting compound is dichloroethylene. It is treated with two molecules of aminobutanol, 2-aminobutanol. This is butanol, this is active position amino group. 2-aminobutanol, two molecules are using here. On heating, in presence of acid medium, it gives this compound where these chloro groups are removed, and but with this hydrogen, one hydrogen are the two molecules, and we get this compound where this is the ethylene part, this is the aminobutanol part, and we get this product, that is ethambutol. Very simple synthesis of this compound. Properties: it is bacteriostatic drugs. You know already about the bacteriostatic drugs. It is highly effective, but it is used in combination with the other drug like isoniazid or ramping. It arrests the RNA synthesis of the microbes. Now, the third medicine of this class is ethionamide. Ethionamide, having trade name, is Trecator SC. This is very simple compound. The starting compound for the synthesis is 2-ethyl nicotinamide. You know already, this is nicotine, and this is the ethyl nicotinamide. They are amide group, so we are calling it nicotinamide. It is dehydrated by eating away some. So we get, you know already, amide gives cyanide group. So we get nitride or cyanide derivative. So we are dehydrating the amide and we are getting cyanide derivative. This cyanide here ethyl cyanide pyridine is, and then it gives this compound. See where the oxygen atom, where the sulfur atom is introducing here. So this is the formation of ethylamide. Uses, it is effective with combination with the other antituberculative drug, and its side effect is anorexia, vomiting, nausea. It is also a bacteriostatic drug. Antimycobacterial drugs, you know already that it has two parts, and we have learned about antituberculosis drugs. Now second part is anti-leprosy drug. So anti-leprosy drugs are, according to your syllabus, only two. Like number one is dapsone and number two is aminobenzoic acid. Aminobenzoic acid is well known compound for you, and another compound dapsone. So I am showing you synthesis of dapsone. Just to know that this is anti-leprosy drug. Dapsone is very simple compound. We are taking this compound where actually this is benzoic acid with acetyl group at this part. So aminobenzoic acid is here, and this is chloronitrobenzene. When these two compounds are subjected to reaction, they form this species. Here simple reactions take place. Here any of this is sodium derivative of them or this chloro. They are reacting together, NaCl forming, and the bond formation between them. Means here SO2 group is joining these two parts. After that it is subject to reduction with zinc and HCl, and then hydrolysis in presence of base, sodium hydroxide rather than. So it gives this both side amino groups with SO2, these two amino benzene are joining together. This is dapsone. This dapsone is used both in leprosy, which is caused by the lepromatous, or as well as some tuberculoidal leprosy also. Both type of leprosy is controlled by or cured by this drug, and it is bacteriostatic. It is useful against pneumocystis coli bacteria. Yes, it is useful in pneumonia also. Its side effects are skin, liver problems, and psychosis also developed by this. Last compound is aminosulfuric acid. Basic structure. Students, this is well-known compound, so I am not discussing its synthesis. And so this we have learned about antibacterial drugs, antimycobacterial drugs. In antimycobacterial drugs, we are learned about antituberculosis drugs, anti-leprosy drugs. Thank you.